Hello, math friends. Today we're going to go ahead and take a look at whether a relationship is proportional. And we're going to take a look at it with tables, with graphs, and equations. Let's go ahead and get started. So, a proportional relationship always has to be in the form of y equals k times x. So this is the form that we're looking for. If it's not in this form, if it has any extras, then it is not going to be a proportional relationship. So let's play a little game. It's called proportional or not proportional. And we're going to do a little sorting. Everyone loves a good sorting game, right? So if we take a look here, we have y equals 4x. Is this in the same form? Well, my y is there, my equals is there, my k looks like it's a 4, and I have my x. So yes, that is proportional. Let's take a look at this one. Y equals 1/2 times k. So I have my y, I have my equals, my k, it looks like is 1/2, and I have my x. Looks good to me, proportional. Now I look at this one. Oh, look at there. Came apart a little bit. Let's group that together. So if we take a look at this one, y equals negative 2x plus 1. If we look at that, negative 2x plus 1, we have our y, we have our equals, we have our negative 2x, so it looks like my k is negative 2, and then I have this plus 1. Is there any plus 1 over here? No. Y equals negative 2x plus 1 is not proportional. Okay? Let's look at the next one. Y equals negative 3x equals y. So they switched the order around, but I know, because I'm super smart at algebra, as I'm sure you are too, I could also write that as y equals negative 3x. I can switch the order. So if I look at that, there's my y, there's my equals, my k looks like it's negative 3, and there's my x. So that is, my friends, proportional. And then I look at this last one. 12x minus 1 equals y. So I have my y. It's on the other side, but that's okay. We talked about that. We can move it over. I have my 12x. So my k looks like it's 12, but I have this minus 1. The buzzer goes off. That relationship is not proportional, okay? So taking a look, proportional, not proportional. The proportional ones are in this form, y equals kx. The k is easily picked out, and there's just a plain old y and a plain old x. Not proportional, y equals negative 2x, and there's something else tacked on. I'm going to give you one other quick one that would be not proportional. I could have y equals 2 times x squared. If you take a look there, there's that x squared, right? X squared is not what we have here. We just have an x, so that is going to be not proportional. Okay, let's take a look at some tables. If we think about what being in the form y equals kx means, it means that there is one magical number that we should always look for. And that is if we fill in 0. What happens if we fill in 0? K times 0. If we fill in 0 for x, what's anything times 0? Well, it's always going to be 0, right? That's what super smart mathematicians know. So I should always be looking for the ordered pair 0, 0. Okay, I'm not done just because it's on there, not a guarantee, but we should definitely check it out. So right here, I see my 0, 0. I start to think, hey, that could be proportional. And now I check and see if I can get it in this form, right? And so I look at my 1 value. That's always an easy one, because 1 times what gives me 3? Well, 1 times 3 is 2 times 3, 6. Is 3 times, yes, yes, yes. This would be y equals 3x. It's in that form. 0, 0's on it. It's proportional. Super fun, right? I look here, ooh, 0, 0's on there. Good chance, right? And so then I go ahead and I take a look. What's 1 times what gives me 1/2? Well, times half. What's 2 times a half? 2 times a half is 1 if you have 2 halves. What's negative 1 times a half? Negative half. Woo-hoo! Y equals 1/2 x. It's in that form. It's proportional. I look here. Ooh. There's a 0 paired with a 1. I know that's not proportional. I look here. I go, huh, there's no 0, 0. I better see if I can get it into this form, y equals kx. So I look at what do I do to 1 to get a 4? I multiply by 4. 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. Looks to me like it's y equals 4x. If I fill in 0 for my x, I could add in that 0, 0 is on there. It is proportional. So sometimes you have to do a little digging, but you should for sure be like, hey, this could be a proportional relationship if 0, 0 is on in your table. Now we're moving on to graphs. Well, what does that mean? If 0, 0 is on a graph, what does that mean? It means it goes through the origin. So 2 of these graphs are doing the same thing, and one of them is doing their own thing, right? And so if we take a look, this graph, it's a line, and what we know is that y equals kx, that equation is the equation of a line, and it is an equation of a line. When we think about the equation of a line, that we know y equals mx plus b. The special thing about proportional relationships is the b is always, we could say, plus 0 here. But we don't do that because mathematicians are lazy. So proportional relationships are y equals kx, and they always go through the origin. So that means that the y-intercept is always 0. So just by looking at it, as soon as I see line, it's got to be a line. Yes, they're all lines. And then it also has to go through 0, 0. Okay? That's how I know. If I get a yes and a yes, I know it's proportional. So I look here. Line, line, line. Is it going through the origin? 0, 0. No. Not proportional. Here. Is it going through 0, 0? Yes. So that's proportional. Is this one going through 0, 0? Yes. Proportional. So if I think about proportional relationships, I'm always thinking about this. Can it be in the form of y equals kx? And I think about what that means. What that means to me is that it goes through 0, 0. That's that magical point that I should always be looking for, whether it be in a table or in a graph. Or we can also take that into consideration for an equation, that means that there's no b tacked on there. So that's all my super smart advice about recognizing if a relationship is proportional using a table, a graph, or equation. Way to go. Have a great day, guys.